The last type of patterns on the junior cert course are exponential patterns. Now you may have seen these a lot in the news in 2020. They look something like this. They grow quite quickly. The goddamn coronavirus is exponential in growth. Now at junior cert, we just have two types of exponential patterns: doubling and tripling. And we're going to look at graphing both of these here now. So you just really have to identify them at junior cert and be able to graph them. So a doubling pattern is something that grows quite quickly. If we start at the number 1 and we double, we get to the number 2, then we get to the number 4, then we get to the number 8, and then we get to the number 16, and then we get to the number 2. So this is my doubling pattern. And this is the pattern 2 to the power of n. 2 to the power of 0 is equal to 1. 2 to the power of 1 is equal to 2. 2 squared is equal to 4. 2 cubed is equal to 8. 2 to the power of 4 is equal to 16. And 2 to the power of 5 is equal to 32. So we just do a little sketch of this. So these are my x values, they are my zeros, my ones up to 5. So 1, 2, 3, 4, 5. And if we start here, if this is the number 1, I'll start a little bit lower. And anything to the power of 0 is equal to 1. So I start down here for 1, and I'll call this 4, 8, 12, 16, 20, 24, 28, 32 up the top there. So let's graph this doubling pattern. Try to do a different color. So 0, 1 is here. 1, 2, 3, 4, 5. So this is my value for n. So when n is equal to 1, you can see that it's equal to 2. So slow growth. 2 would be equal to 4, still slow growth. 3 would be equal to 8. So it's actually climbing quickly. 4 is equal to 16. It's really climbing quickly. And 5 is equal to 32. And you can see this exponential growth curve looks like this. Now, the tripling, 3 to the power of n, is going to be exactly the same shape. It's just going to grow a little bit quicker. So let's have a look at tripling. We start at the number 1, triple it, 3, triple it, 9, triple it, 27, triple it, 81. So that's 3 to the power of n is my tripling. 3 to the power of 0 is 1, 3 to the power of 1 is 3, 3 to the power of 2 is 9, 3 to the power of 3 is 27, and 3 to the power of 4 is 81. Now, if we do it on the same graph, they're going to have a point of intersection at 1, at 0, 1. And it's just going to climb above it here when 1 is equal to 3. This one. When n is 2, it's equal to 9. About here. When it's equal to 3, we're already at 27, so you can see with the tripling it grows really, really quickly. So if you were asked to identify in a graph, I'll do one more, something like this. This is your 2 to the power of n. What can we say as we go left? The number in front of n increases, and let's say this is approximately 4 to the power of n. So if you're given 3 exponential graphs to identify, as they get closer to the y-axis or they grow bigger, quicker, the number in front of n increases. So that's pretty much all the knowledge you need. You need to be able to graph them. You need to be able to identify them. So go now and accurately try and graph 2 to the power of n and 3 to the power of n and see do they look like exponential growth.